testing the TEKIN RSX speed control using the Minipro Dyno. I've tested a few speed controls with this already using the 13.5 turn motor set to 6 amps for blinky mode to show up the performance. Now, testing for blinky mode 17.5 shows up the performance of speed controls quite well. If you're running boosted or modified, some of the parameters of these speed controls don't matter so much, as you get more than enough power and braking with those sort of classes. But with blinky mode, you really need a speed control that is excellent on brakes especially. Now for this test, I'm going to try a few different extra curves on the software. And if you look at this, there's some I've tested up already. We're showing some very unusual graphs. I've got 3 speedos on here actually that I've tested. And what I'm going to do is test the speed control with 10% throttle initially, then 50%, then 100%, and then do 100% brakes. This shows up some interesting things about speed controls. One, when you're running at 10% throttle, just trying to maneuver to the right point at the starting grid on the line, you want to be able to move very slowly. And at 10% throttle, some speedos like this one, the car doesn't actually move. Others move quite well. Got a little bit of revs there just going up at 10%. And then the next part of the graph is holding 50% for about 4 seconds. And it's very interesting, we got the amp draw here. And you can see to maintain a 50% throttle, some speedos pulse the motor to maintain the speed, and some have this constant amp draw here. And so this one here draws quite a lot of current compared to the others, which is going to flatten your battery if you drive in a lot of intermediate throttle settings, whereas these drawing less current. Even the average of this one's higher. Now when we hit 100% throttle here, we hold that for 6 seconds. You can see that the rev, this is the RPM, goes up in a fairly constant curve as it peaks out and just creeps a little bit more towards the end. They all seem to get to about the same revs in the end. The steepness of the curves, well, the steeper it is, the quicker it's accelerating. So the brown one here definitely accelerates best. It's got a nice curve at 10%, nice curve at 50%, and a quick curve to 100%. Now looking down here, the brown one goes down there. It's actually got very poor brakes. The blue one here, the steeper this curve, the stronger the brakes. You hit full brakes, you want the car to stop as fast as possible, steeper the better. So the blue one's got the best brakes. It's got a good curve there, curve, so it's very similar to the brown one. Hardly any difference really, just a little bit there when it hits 100%. And the amp draw is with that brown one. The amps here showing voltage. Amps is the sort of dark mauve one. Amps there. You can see that it actually has quite a high pulse when it hits the 100%. Seems to draw a little more amps than the others. That's just under 40 amps. This red one, by the way, as you see, because it was not really moving for 10%, when it hits full power, it's got to move the flywheel towards the highest amount of amps compared to the others, as they've already got the flywheel moving at about 2,500 RPM, so the pulse of current is less. But even so, these graphs are very interesting. Now, the Tekin. Now, this is a very interesting speedo. The previous model that I used in my own car was this one, the standard RSPRO, which was a very good speedo and was used for a lot of people. Unusual, it's not a metal case, so it used to get very hot. The new one has got an aluminium case. It's bigger and it's obviously heavier. This one was quite lightweight. Also only came with a tiny capacitor. I think the new one does too, but I've got a big one on that one at the moment. Okay, getting to why these speedos are interesting. Well, you have to connect them up really to a laptop to see all the full adjustments that you can do. This old one, I can't update it to the latest firmware software. I couldn't update it, but it doesn't matter, it's still got all the same features. And if you look at this, you've got setup, brake, throttle, timing, curves that you can adjust, and it tells you what you've set here. But the interesting things are, let's look at the brakes, the most interesting. It's got, besides drag brake and brake strength, it's got something called active braking. Now, no other speedo I know has got this, and it actually increases the brakes dramatically. I'm not sure how it does it, probably by putting on reverse pulses to the motor like you're trying to go backwards. So it'll be interesting to see what happens to the current when this is set from 0, and then we can set it up to maximum. There's also something called push control, which is supposed to simulate an old brushed motor where the car would coast if you came off the power. So I think it maintains some power when you go to neutral. We'll look at that as well, see what happens. On the throttle side, we will obviously be setting it to blinky mode, and we can look at things like power limit, which is like a torque control. Curves, we won't be using them. You can put exponential curves on, you can do that on most transmitters these days. The setup is just normal. You've got to set up while the motor goes back, forward, or all the rest of it. Now there is an advanced settings. I can't get them on this one, so I'll show you the timing. We'll use the locked spec mode, so you can't adjust the timing. On the new software, which I'll be showing you on the when we connect up the RSX, you can adjust the frequency as well. Unfortunately, you can't do it on this one. Anyway, I will do a test on this one just to show you how things have advanced from that to this one. Testing the old TEKIN RSPRO. It's on default values, which means 100% brake, 100% torque, no push control. I've also taken no drag brake. I've set it up to the computer, brake, throttle, neutral. So you can't change the frequency on the software on this one, so it's whatever it was. Going to start with a 10% throttle, then 50% throttle, then 100% throttle, then 100% brakes, and we get the curve on the screen. So we can connect it up. We'll do run test sequence 1. And it comes to a stop, so we can look at the graph now. I'll just looking at the graph. We can see that here is the first part, the 2 seconds at 10% throttle, and it's one of those speedos which actually doesn't move at 10% throttle. There's some that do, some that don't, and I'll investigate how we can adjust that so that when you're trying to creep to the line to get right on your grid position, you don't have to push too much throttle and then it jumps forward. Anyway, so that it didn't move. Then it hits 50%, which you got. This is a current pulse here, and then you see the current basically drops away raggedly, but fairly linear. And the acceleration, the blue one here, is a nice steep curve. Then as it reaches the 50% speed, it tapers off, and then it hits 100%. You get another current pulse, which drops away like that, and the speed goes up to the maximum where it peaks out, about 25,000 RPM in this case, and then it hits 100% brakes, which come down. Now the steeper the bet would be the better. This is not that steep, but anyway, it goes pretty linear right down here, which is good. Linear is good, which means that when you approach the bottom, or when your car is virtually going to stop, you've still got a bit of brakes. It goes down to 1000 RPM, then dies away. We can look at the maximum RPM is good, right up here. This green line is the voltage of the LiPo, and you can see it drops as soon as the current hits, drops, recovers. And this is the amps. It's a pulse, so it's over 65 amps, and there's another pulse there, over 50 amps, and you see the current drops away down to here, which is only about 12 amps at maximum revs, and then there's no current when it's braking. And it'd be interesting to see when we put things on like braking, active brakes, where there's any current draw, because I suspect it might be applying reverse pulses to stop. The RSPRO, just on the first test. Now I've connected up the hot wire, so we're going to look at what we can change. Now on the throttle side, the speedo didn't want to move at 10%, so we're going to have to turn the throttle minimum up. It's on 2 at the moment, so I'll put it up to, we'll try 5, which isn't much, but it's something. And now on the brakes, we do the brakes at the same time. Now we've got the brakes at 100% strength, but we've got something called active braking. Let's put it up to max and see what happens. I can apply the settings here. Sequence 2 on the RSPRO. You've increased the minimum throttle a little bit, and we've got maximum active brakes. Start sequence test 2. Already we can see, and you heard on when the motor was trying to get going, and it actually did get a few revs down here. It's the brown curve, about 500 RPM. So it means that we now can actually move slowly. Best to get about 1000 RPM, so we might add a little bit more and test that again. Then you've got the acceleration curves, basically the same curve at 50% to the same point. Current pulses, well, about the same, and then at 50% you can see the current going down here. At 50% it hits again, current pulse is about the same now. Curves are identical, but now the brakes, this is where it gets interesting. The steep line is the second test with the active brake, really steep now, really working. But look what happens down here. This is the current. It, as I suspected, it's going to start applying some sort of reverse current pulsing. It doesn't apply any right at the beginning of the curve. Then there's a lot of pulse in here to keep it up, and as you can see, the curve is nice and steep. There's the voltage. Voltage actually jumps at the start, like it's got some, putting back some voltage into the cell compared to the original green one, and then it dips there as the current is pulsing. and you can see the curve pretty steep right down to 1000 RPM, pretty strong, and then just fades away right at the end. So very good brakes. But this current pulsing is, if you use a lot of brakes, is going to heat your motor up quite a lot. If you're going to use lots of brakes, you're going to have to watch that, but the effect is excellent. I'll do one more test with a little bit more down here. There's not much more we can do on this speedo. We can't change the frequency or anything. Then we move on to the RSX. The final test on the RSPRO. I've just increased the throttle minimum from the original test was 0 or 2, I think. Then we tried 5. I've just put it up to 8 to see if that gives you a smoother, very low control. We have to apply the settings. Sequence 3. As you heard, probably much better at the beginning. Seems to be some little bit of throttle control. That was with the throttle at 8. If we zoom in, we've now got a green curve down here, and you can see it's got a little bit of revs, about just over 1000, 1400, something like that. And then it hit the 50%, and you've got the curve, same shape curve as before. Current pulses, well, we're looking at current is one of the red ones here, and again at 100%, big pulse of current drops away. And then the brakes, again, should see the same, so I didn't change the brakes. Maximum brakes, the green line, and the red line for all this pulsing on the brakes here. The original one, the blue, there was no current, it went along here. So I've connected up the RSX so we can look at the software now for that. And as you can see, we're now up to a version 2.7.2, and the other speed control, I couldn't update it, so it was lower. And what do we see on the new version? Well, if you look at brakes again, down here you've got a frequency that you can adjust. The other parts on here, there's a thing called RPM brake, which wasn't on it before. We've still got active braking, push control, brake strength. There's a thing called active drag as well, but we won't be looking at that initially. The frequency can be changed. As you can see, weakest it says 12 kilohertz and strongest 750 hertz. So we can test them. The RPM brakes, just brake strength, increase as RPM reduces. That's very useful. Some speed controls, as you slow down coming up to the line to stop, the brakes just disappear and you just sort of overshoot, which is quite annoying. I've seen speed controls where you can have strong brakes at high speed and weak low, or weak at high speed and strong low. But this one, we'll check it out and see whether you can tune it exactly as you want. Looking at finally at the throttle, again got a frequency here, and it's the same as the brakes, maybe, no, 2 kilohertz aggressive, 12 kilohertz mild. We've got a torque level. So timing, we need to set that lock spec mode, that'll be put on, and so no timing. Curves will be linear. We've got to do a setup. This hasn't been set up yet because I've updated the firmware, which resets everything back to default. Tekin RSPRO. Basic default settings will be test 1. It's 100% throttle, 100% brakes, no push, no active brakes, 6 kHz forward, 6 kHz brakes, no drag brake, etc. and blinky mode. Let's do test sequence 1. Quick look at the graph before we modify it and do the next sequence. As you can see, and you probably heard that when it, for the first 2 seconds at 10% throttle, didn't actually move the flywheel. It's exactly what we found with the original Pro, the one that came before this, the RSPRO. And then there's a big current pulse as it hits 50%. And the current drops off and it hits a point here, we hit 100%, accelerates up to near 25,000, applies the brakes, and you've got a pretty smooth brakes, and then he starts using off about 2,000, just curves off. I'm going to make some adjustments and we'll retest. Make a couple of changes. Throttle minimum on the Pro we had to put that up to 8. I'll put it up to 8 again, and then on the frequency I think we'll leave the frequency the same, but on the throttle, but on the brakes we've got active braking, which I'm going to put up to maximum and leave the frequency the same at 6 kHz. So we apply those settings and then we do the test. Test 2. Looking at the graph, see, and you heard at the start it actually gave it some revs, and now we put the minimum throttle to 8. Again, as on the previous one we tested, about the same, 1,400. Interestingly, the acceleration at 50% actually went up to a higher throttle, higher revs point. The current again is about the same, then it hits the 100%, curves the same, slightly higher RPM, but the brakes, with the active brakes, as you can see, very steep, lots of brakes, and then here as before you've got this massive added current, not quite the same as on the Pro, but a big pulse of current here as it maintains the brakes down here, down to here, where it begins to curve slightly, but gets down to about 2,000, then dies. Next thing I can do is I'll change the brake frequency. We'll have a look. For the next test I'm going to change the throttle frequency. We'll try minimum because it says that's the most aggressive, so we'll set that to 2 kHz, and then on the brakes we'll also set the frequency down to minimum because it says that's the strongest. We'll apply them. Test sequence 3 with the minimum frequency for throttle and brake. Now the third run was the green, yellow and red. So the green, we need to look at the green curve here. Now this is minimum frequency. Again, the minimum 10% throttle seems to be about the same. And then the acceleration, well, it's starting there, it goes up about the same as before, virtually identical to the brown one, just a tiny bit more there, so it's slightly ahead, but it peaks out basically the same. And then the brakes, it comes down exactly the same, and this was on the minimum frequency on the brakes, follows it down. Then there's a lot of pulsing going on here. The red one has got pulsing up and down, but the curve itself, actually I can take off the current curves and hide them. The curves are identical on the brakes, and that was default frequency of 6 kilohertz and the minimum is like 750 hertz, and the acceleration, these two curves. So the frequency, as far as I can see, didn't really make any difference. There is one extra test we can do with the brakes. Test sequence, which would be the fourth test. I'm going to have a look at this curve here. It's called RPM brakes. Adjust brake strength increases as RPM reduces. So that was set a minimum or off. I'm going to set it to maximum. We're going to leave the brakes at 750 hertz, and we're going to leave the throttle at the 2 kilohertz aggressive. We're not going to change those things. So apply the settings. First part was fine, and then the acceleration, we're looking at the green graph as opposed to the blue. Basically it's exactly the same. Current draw, again about the same, hits the current draw there. Maximum RPM there, about the same. Then the brakes, well, this is with the RPM brake enabled, goes down here. Massive current pulses going on here. We can look at one current pulse, as you can see, pulsing up and down. The other one basically the same. And then well, they fade off exactly the same place, so I'm not quite sure whether that RPM thing, brake RPM thing, what it's doing on this sort of test. It's obviously not showing up anything. In fact, these curves are almost identical now. While we're at it, I'll make one more test by changing the frequencies on the throttle and the brake to be 12 kilohertz on throttle, and brakes will be so 12 kilohertz, which is weakest. We've got the RPM brake maximum, we've got the active brake maximum, and the brake strength 100%. We apply settings. The frequency for brakes and throttle set to the maximum, which is the weakest setting. Other settings such as brakes, active and RPM, everything is on maximum. Well, that was interesting because the brakes sort of packed up. I hope there's nothing blown, so let's have a see if anything on the graph. Well, at the moment, that last sequence was number 2, which was the brown curve. The actual throttle picked up a bit better at very low revs, 10%. It's, throttle is at high frequency, picked up a bit smoother, is probably what you'd expect. Then the acceleration curve, current about the same. Acceleration not quite as good here, but that's only 50% throttle, so but then it picks up 100%, basically goes to the same point. Brakes, the braking comes down until it got to here, then the brakes just packed up at just over 3,000. So I hope that's not a fault. You wouldn't want that to happen on the track. As far as everything else goes, you've got these current pulses, but the current pulsing is much less at on this break point here, at the high frequency on the brakes, and then it packs up there. I'll take the RPM braking off and see if that makes any difference. With the RPM brakes disengaged, this is a B test number 1 it's going to be under. I think it broke down properly that time. Test number 1, which was the blue curve. Blue, bottom end same, acceleration, well, it just jumped ahead of the rest, but the curve is the same. Up the top, brakes, hits full brakes there, comes down, and then it's the pink. If I take away the others, the pink is the pulses of current, and the curve is the blue one. As you can see, the blue one continues down quite nicely and curves off just at the bottom. That was the one with the RPM brake on max. It just sort of didn't like it, so I've taken the RPM brake off and it's back to normal. But on the shape of the curve, the green one holds a much straighter curve down to here, 1,000, and that was the minimum frequency. So it looks like the minimum frequency works a tiny bit better on the brakes, right at the very bottom end, but not much. Quick comparison of the TEKIN RSX and the RSPRO. Okay, the RSPRO is the blue one, 10%, 50, 100 and brakes, and the latest RSX with active brake max as well is the brown one. You can see they were both set on the throttle of initial 8, which gave them very similar bottom throttle feel. The RSX picked up a lot quicker on 50% throttle, but that hardly makes a lot of difference, depends where you're holding the throttle. But when it fits 100%, they both accelerate about the same, not really much difference. The Pro just lagging behind because it started at a lower RPM, but when they hit the brakes, look, they're identical braking performance right down to the bottom. In fact, the RS Pro actually was just a little bit ahead, slightly better than the RSX. So that is the difference between the old RS Pro and the RSX. You can look at the current as well, and you can see that it's very similar. Current pulses here, they drop away. Current pulse at 50%. The Pro is actually a little more current pulse there, but nothing much. And then the active braking drops off, and then you've got this pulse in here on both of them. So very little difference at all. Looking at the results of 3 different speed controls tested the same way, with 10% throttle, 50% throttle, 100% throttle and maximum brakes. I tried to find the best settings of each speedo. Pulled up the 3 here, the McLaren MMAX, the Nosram HC stock spec and the TEKIN RSX. Now I've taken off the amps and the volts. We just look at the RPM initially, and in the first part of the test, 10% throttle, the blue one, McLaren, it had no throttle at all at 10%. Then you've got the green one, the RSX. When I adjust it to a minimum of 8, you've got 1000 RPM, which is virtually perfect. The Nosram HD, 10% gave an awful lot of revs, a lot. I don't know if that can be adjusted out. Then the 50% throttle. Well, because the Nosram was already doing some revs, it was a bit ahead of the curve, but it started peaking out here. The blue one had to start at 0. Got a good acceleration curve, and overshot the others a bit on RPM, so but that was only partial throttle, so you're not really aiming at a fixed speed. It shows that they all accelerate about the same. Then at 100%, that's when you want to see which is best. Well, they all accelerate basically to the same point, just under 25,000 RPM, so there's not really much in it at all. But the brakes, a huge difference. The steeper the better. The brown one, the Nosram, just ahead, seemed to start a bit quicker than the others, but maybe the green one, the Tekin, is a bit steeper. Yeah, looks steeper, doesn't it? And in fact it is steeper because it keeps the brakes on right down here ahead of the Nosram now. Nosram just under, and it keeps it right down to, starts curving off about 2000. Nosram a bit steeper down to maybe nearly 1000. So the low revs, the Nosram is just ahead. The Tekin sort of goes away about below 2000, but still some braking. Whereas the McLaren, well, I haven't tried the latest firmware software update on the McLaren, but the brakes were quite weak, although they're linear, and they stay linear down to about 2, 1 and fade away. Were not the greatest. Now the next thing I can show is the current. Very interesting, because we've got the Nosram, we've got the Tekin, and then you've got the McLaren. Well, looking at these, you can see that the current, when they're trying to move off the line, the Tekin current is very low, even though it's got some revs going on. The Nosram, because it's got a lot more revs, it had a lot more current and a bit of a pulse to get it going. The McLaren didn't actually move off the line, the pink one, so it's got no current. Then we hit 50%, and there's a big jump obviously in the current with the Tekin and the McLaren, there, the pink one, both giving a big pulse of current to get it going. Now here's quite interesting. If look at the pink one for the McLaren, it's obviously pulsing the throttle to maintain the speed from 100% to 0%. That's one way of keeping the efficiency good. Whether or not it works better than these others, which are basically a little bit of pulsing but basically quite linear. So McLaren is quite a difference, and the average current is much higher on the McLaren. It averages out, see, about 18 amps. The others are dropping off down to 10 amps, and then it hits full power, and they all jump and give about the same amount of current. All three of them go down to here. Then it hits the brakes. Now this gets interesting, because initially when they hit the brakes, the current sort of drops to 0, and then on the Tekin, which has got push brakes, it starts applying a lot of amps, probably reverse pulses to slow the car down, and that will cause heating effect. But the graph of the Tekin is the green one. It does give the best braking just ahead of the NOS-RAM, but the NOS-RAM current is purple, and it's basically no current along the bottom, as is the McLaren, no current along the bottom while it's braking. So interesting curves. The speed reached by all of them about the same. So the acceleration, you can mess around with this with your minimum throttle power settings, and the acceleration curves seem to be about the same on all these speedos, but the brakes are a lot different and the current draw is different. This sort of current at partial throttles is going to use up more power and cause possible additional heating in the speedo than these ones which have linear amp draws. 100% are the same brakes. Unusual. One more quick test I can possibly do on a speed control is to do with the capacitor. A lot of people say and think that the larger capacitor gives them better brakes, but these capacitors generally are fitted just to help with pulsing and keep the speedo switching on and off without overheating it, especially at low speeds. It's just to protect the FETs and help them. A lot of people think that it gives better brakes or better acceleration, but generally these speedos and the power of the wires and everything and the lipos are so powerful. The addition of a capacitor, in my experience, it makes no difference, but you should always have a capacitor. It does need one just to protect the FETs generally from spikes. The Tekin is exceptional in that it only comes one tiny little capacitor, which obviously they tested and found sufficient. Some people like to put a 4-part on, which is a bigger capacity, and some people even buy these massive ones like this 250,000 microfarad one, and there is, I've seen 1 or 2 or 3 farads as well. It's massive. So it might work for drift cars or something which you're working a lot at partial throttle, which might help prevent the overheating and also give a smooth response. But for maximum braking, maximum acceleration, I don't think so. So just to show, I've tested this one with the single capacitor. I then can put this big capacitor on it. There's no point putting the intermediate. We go from one extreme to the other. Run the tests and the graphs and see if we can see any difference. Testing the RSPRO with the very large capacitor fitted. Kept the little one on as well. Just see if it makes any difference. I've got the graph loaded up from the test with just a little capacitor on, and so we run the next sequence here. So looking at the curve here, let's just check the current on for you. So we've got, let's just look at the RPM. I'll take the two currents off. Well, you've got the TEKIN RSPRO original curve and the one with the massive capacitor on. You can hardly tell them apart. You keep amplifying, and you've got the blue and the brown one. They're completely overlaid. Let's do the look at the currents. Take the revs off, and you've got the pink and the mauve. They appear to be identical. Absolutely no difference whatsoever. There's a bit of pulse in there. Let's put the voltages back on. In voltages and the revs. There's the voltages. See the voltage goes along there, dips, small jump there. Amazingly the same. So, does a big capacitor help on the speed control there? Well, this test shows it doesn't. Whether or not you can feel any difference might be psychological, or maybe it works with other wines. This is a 13.5, maybe it works with modifieds, or as I say, I think it's mainly for very slow moving to get a very smooth action at low revs, rock crawling or something like that, or drifting.